So let's solve this couple of questions from the MSBTE exam on mensuration, specifically on cylinders. So we are going to take these two problems on one from summer 2018, which is going to be a straightforward problem for 3 marks, no major hiccups there. And another slightly twisty problem in summer 2019, question number 2D for 4 marks. This is a very twisty problem, number 1. So we have to just read it twice to see what they're asking. The second thing about this question is, if you recall, I said sometime mensuration might come. Usually the syllabus, as per the official syllabus, it's for 8 marks, but definitely it comes for 10 marks. But sometimes it can go up to 14 marks. So this is one of the questions which has come in last 2 or 3 times in the exact same pattern, question number 2D for 4 marks. So this is the question, or this is one of the papers where mensuration has been asked for 14 marks. Okay, so that's kind of the importance. And every time whenever there's an extra 4-mark question coming, looks like it always comes in question number 2D. So that's kind of a side note. So that way this is kind of an important question. So we'll tackle that. And like I said, if you remember the formula and with the help of calci we can calculate, there is no room for calculation mistake and we can get going. So the next 2 episodes or topics, we'll just cover these 2 problems one after another. And I'll see you there in the next topic. So let's address this question on mensuration. The topic is cylinder. Okay, so the question is, find the capacity of a cylindrical water tank whose radius is given and whose length is given in meters. Okay, and since the question explicitly says cylinder water tank, the first thing that should flash in your head is, okay, they're talking about cylinder. Okay, so that's half battle won, because you don't have to guess what the 3D object is. Before solving, always read the question twice and check out and break it word by word and understand what they're asking about. So the first thing is they're asking to find the capacity. Capacity is nothing but volume. Okay, how much a particular object can store. That's another way of saying volume. So that means we know they're asking about volume, and we also know that volume is always measured in cubic units. So this we should not forget. Okay, and then we have been given the dimensions. So the best thing to do that is always have a visual. Okay, now we know that it's also a cylinder. Okay, so we need to find the volume of a cylindrical water tank. So we should always draw this visual here like this, so that okay, we know all the dimensions mentioned, what are the things we would need for a cylinder, and we need to find the volume. So we know that. And then what we do is we just solve the problem, because what is given is a radius of 2.1 meters and length is 5 meters. So the dimensions here, the units are in meters. So that's also given. Okay, now let's kind of solve the problem. So let's start the solution. It's going to be a very simple solution. So we have this cylinder and we have been given radius is equal to 2.1 meter. So this particular thing is going to be 2.1 meters. Okay, and if you see this as a center, and the height is going to be 5 meters. Okay, the height of the cylinder, which is given by this, is going to be 5 cylinder. And the ask is, what is the capacity or what is the volume? Okay, so we know from the volume of the cylinder formula, volume of a cylinder is equal to pi r square multiplied by h, the height, cubic units. Okay, and if you plug in the values, 3.14 for pi, the radius is 2.1, and we have to square it up. So we need to take the radius twice, 2.1 into 2.1, and then the height is 5 meters. We take height and we multiply, we get in decimal, which is 69.23 cubic meters. Okay, since the unit is in cubic units, we need to put in meters, because that's what we have given. Okay, and that's the simple answer, and that's straight whatever marks it is assigned, 2, 3, 4, whatever that is. Okay, and like I said, if you don't memorize, or if you're not able to remember the formula, don't worry about that. Always remember this trick. Volume of any 3D object is always going to be, whether it's cylinder or a cuboid or any shape, it's going to be always the area of the base multiplied by the height. Whatever is the shape of the base, the area of that particular shape in the base multiplied by height. In the case of cylinder, we always know that the area of the base is going to be a circle, and then we already have the height here, and the area of the circle is pi r square, and then the whole overall formula becomes volume is equal to pi r square into h. So like I said, just remember this. If you don't remember, don't worry about it. Just think about it. Okay, anytime volume is asked, I need to just multiply the base of the object, whatever shape that is. In this case, it's circle, and I need to just multiply by the height. In case of cuboid, it will be just length into breadth into height, and so on and so forth. So that's how you need to solve this. So, and that's the That's why I said mensuration is all about formulas, and if you remember the formulas or if you know how to derive them on the fly, you can easily solve the problem. But don't do any calculation mistakes. Use calculator to solve all this equation, okay? And don't try to forget to add the cubic meter. If the dimension is not given in specific units, just say cubic units. That should be all before we move on to the next topic. Let's take another problem on mensuration, specifically on cylinder, and let me read out the question. A metal strip having sides 17 by 7 by 5 in centimeters is melted down and minted into coins, each of diameter 1.4 centimeter and thickness of 0.08 centimeter. Assuming no wastage, how many coins can be minted? Okay, so a lot of words in the question, and the shape of the objects are not directly given. We have to visualize. So before we start solving the problem, let's break it down word by word and get our all facts together and whatever hints and data is given in the question, and then we'll solve the problem. So first and foremost, based on the question, we would know easily that it's a mensuration problem because they're given dimensions and they're asking to calculate some of the things that might require some calculation using formula, okay? And what are the two things they are giving? One is something of a metal strip, okay? As soon as they take a metal strip, and since they're also talking about a length and breadth and height, kind of three dimensions, so we know that this is going to be 3D object, and a metal strip in 3D is nothing but a cuboid. So we know that that's the only way it can be, okay? So that's the first hint. And the second hint is that they're talking about another shape called as coins. Coins, we already know how they are although they are circular in shape, but it still has some thickness, so it's going to be cylinder. It's going to be cylinder with a very small thickness, and that's your clue. So don't do the mistake of assuming coins to be circle and take that as the shape. You'll get the answer wrong. Always see what are the dimensions given. Since they're given two dimensions, the diameter and the thickness, and since coin, we have seen all the coins in terms of money coins, it still has some thickness, okay? And the proof for that is a thickness of some dimension is given 0.08. That should be a clue that this is not a circle and this is a cylinder. So make sure that you do not do that mistake, okay? Don't take it as a circle, okay? That's the most important thing. So now you know that it's a combination problem where you have a combination of a cuboid plus a cylinder. That means you should be knowing the formula for both, and both are 3D objects, okay? And now let's see what they're asking. Assuming no wastage, how many coins can be minted? So when they're talking about how many coins, so they're basically asking you the volume. It's a basically volume question, because based on whatever is the volume and how much melting can be done, the number of coins minted will be the answer, okay? So that's another hint. So all things are like twisted here, where we have to do something in your head where the shape of the object is not given in both the cases, and they are not directly asking you to calculate the volume or capacity. So in that case, we have to always assume that we have to read the question properly word by word to understand where are the hints. The hint is over here. So how many coins can be minted is nothing but what is we need to calculate. It doesn't mean that it's equal to volume, but it's a volume based question, okay? It's a volume based question based on the volumes of these two shapes, okay? And like I said, always the best thing is to draw the visuals of all the shapes in the question, okay? And let's do that before we jump into the solution. So in the solution, we know that we have a cuboid. This is a cuboid, okay? And this is a cylinder. Although I've pasted the visual of coins, but everything is a cylinder if you see here, okay? And let's put all the dimensions that they're given. For the cuboid, they're given us the length 17, breadth and height. So everything is in centimeter. And the other thing for the coins, which is cylindrical in shape, if you see this, like I said, it looks circular, but it's a cylinder because it has a small thickness. So this piece is the thickness which they have given as 0.0 centimeter. And they're talking about a diameter. The diameter is this whole piece from here cutting across the whole piece. If this is the center, let me remove this, hold on. Okay, I don't know why I put that there, but if this is the center, the diameter is going to be cutting across everything. So this piece is the diameter, okay? And the diameter they are given as 1.4 centimeter, okay? So if you see the coin dimensions, we have the thickness of the coin. If you put this coin down like this, the thickness becomes the height. So the thickness is nothing but the height of the cylinder. Thickness of coin is equal to height of the cylinder, because if you just put this coin flat, you will see this is the thickness. Okay, this is the thickness. So if you see this portion, or if you see this portion, so that becomes the height. It's a small height, but it's a height. Okay, and since they're given the diameter, we can easily calculate the radius by dividing it by 2, and we get 0.7 centimeter. So we have all our ducks in a row now. Let's see what we need to do here. Okay, so we know that the volume of metal strip, which is a cuboid, is nothing but length into breadth into height. So we multiply all the 3 dimensions and we get the answer in cubic centimeters. Make sure that you always write this properly, the unit of dimensions. It's 595 cubic centimeters. And the volume of the coin is going to be the volume of the cylinder, because we know that coin is a cylinder with a small height, and we know the formula for a cylinder, which is pi r square into h, and then we put the value of pi, the radius we have found it from here. We have to multiply it twice because we have a square, and then we take the height and we get the volume of the coin. Volume of one coin, it's actually volume of one coin. Okay, volume of one coin is equal to 0.123 cubic centimeters. That's what we get. Okay, so now the question is how many coins we can mint. And if you just go back to our old way of representing the data, with one coin is equal to 0.123 cubic centimeters. Okay, so the volume of one coin is 0.123 cubic centimeters. So if I have a huge volume of 595 here, 595 centimeters, that's the amount of metal I have, then how many coins I can print? So you have to just cross multiply, and if you multiply one by anything, it's going to be the same. So in essence, what you're going to do is number of coins minted is going to be the total volume available divided by the volume of one coin. Okay, that's what we have. That is the total volume of the whole metal strip, which is 595, divided by the volume of one coin, which is 0.123. And when we divide, we get this answer in decimal. And that's funny part, because I don't know why MSBTE has this all typos. They say that there is no wastage, assuming there is no wastage. That means the number of coins should be even, there should not be any wastage. Well, apparently looks like there is a wastage here of 0.398, but don't worry about that. Don't get confused saying that they have not given you wastage and you're getting in decimal, so maybe you are wrong. Mostly MSBTE always has typo issues, so you can go with your problem. Just do the calculation properly using the calci. So if this is your decimal answer and the number of coins cannot be in decimal, because we cannot say you take a 0.398 coin, so we'll just ignore the decimal part and we'll just say it's going to be approximately 4837 coins. That should be your final answer. So that's how you calculate. So again, the hints are, read word by word. You will get the shapes based on some hints and see what they're asking. Sometimes they'll not ask you to calculate the volume directly. They might twist this question saying that how many coins can be minted, what is the capacity of that, and blah blah blah. So that means it's a volume based question. So calculate the volumes and do that. And just like a friendly reminder, in case in the exam you are not able to remember or recall the formula for any of the objects, so far I have never told you to mug up anything yet. So always remember, if you remember the shapes, you can calculate the formula on the fly. So if it's a volume of a cylinder, the volume of any 3D object is going to be the area of the base. Whatever is the area of the base, okay, whatever shape that is. In this case, it's circle multiplied by height. Okay. In the case of volume, since the area of the base is circle over here, if you see it's circular in nature, so you just you say pi r square and into height. Okay. Similarly, for the volume of the strip is going to be area of the base, which is going to be a metal strip. Okay, and it's going to be cuboid. And since it's going to be cuboid, it's a rectangle in shape. Cuboid is nothing but all the sides of the cuboid are rectangular in shape, and the area of the base means area of the rectangle, which is going to be just length into breadth, and then finally you multiply by this component, which is going to be the same in both the cases. Then you get L into B into H cubic units. So that's how you remember. So if you remember this way of calculating, either you don't have to remember the formula, or if these two formulas are easy for you to memorize, just memorize these two. And for all the other 3D objects, we can derive based off the cylinder itself. So there you don't have to memorize, whatever works for you. So that's pretty straightforward, and then that's you pocket your marks, and then we can keep going on to the next topic.